In this video, we're going to cover molecular dynamics in ICM Pro, particularly focusing on MD simulations of virtual screening hit lists. So this approach is meant as a validation of your virtual ligand screening hits. For example, we want to look at the hit list and see if there are any dynamically unstable ligands that we can filter out from our screen. So this will help with that as an extra filter in your virtual screening. MolSoft has integrated OpenMM molecular dynamics libraries as described in the 2017 paper by Eastman and colleagues. Thanks to the GPU optimized code, OpenMM can deliver impressively fast molecular dynamics simulations, achieving rates of around 3 to 12 picoseconds per second, or up to about 1 microsecond per day, even on relatively inexpensive hardware, such as a gaming workstation. What makes this a particularly powerful tool in our workflow is the direct binary interface between ICM and OpenMM. This allows us to seamlessly transfer molecular objects from ICM to the MD engine, run the simulation, and then collect the results and the resulting trajectory snapshots directly into what we call an ICM conformational stack. This tight integration streamlines setup, execution, and analysis of your MD simulations within a single environment. For example, once you've run the simulation, you can do a variety of different calculations, such as calculating docking score of your ligand in each snapshot, calculating the RMSD, RMSF, contact areas, the RTCNN score, which is our neural network docking score, our physics-based docking score, a GBSA delta G binding estimate, and other tools such as clustering your snapshot. But in this video, we're going to mainly concentrate on looking at the hit list. So the script runs, the MD in ICM, it runs this script called run md open mm.icm. You'll find it in your ICM distribution. To run the MD on a series of putative complexes in a virtual screening hit list, you call ICM, you call the script, which is in the /bin directory, and then you have some arguments. This means add waters. This is the time of the simulation, number of confirmations or snapshots you're going to store. -m means that you'll apply MolSoft's minimization and relaxation before the MD run. And this option -RL restrains part of the system far from the ligand, which is ideal because we want to focus on the binding pocket. And then you need to provide the docking hit list and the receptor object. The statistics on RMSD and RTCNN score, and then once the MD simulation is finished, you'll get statistics on RMSD and RTCNN score. And the procedure is useful as an extra validation step in hit selection for experimental follow-up. I'm just going to show you the steps to do this. So I've already run a docking run, so I'm going to go docking open project. It's going to go to ICM doc and choose open. And the docking project name is CR_1M17. This loads up my docking object that I previously docked to. And then I need to make the hit list. So I go docking, make hit list. I browse CR17 and the object file with the docked objects and go OK. So this makes the hit list. You can see at the bottom we have the hit list table. You can browse the ligand bound. If you just single click, that loads the ligand into the structure, and you can browse. But we want to see how stable these docked complexes are. They have good docking scores, physics-based score, and RTCNN score. They're good, but we'll see how stable they are. In this example, I only have 3 in my hit list, but obviously you'd have more. If you don't, for the ones you don't want to refine, you can delete them. So first, you need to save the hit list as an ICB file. So you do that by right-clicking on the hit list table, choose Save As, and then choose the .icb here, and give it a name. And then we use the object file here, which is in your docking projects that you already have set up as the object. So you go to the terminal window, and then we have to provide, at the moment it's only on the command line, but maybe in the future it will be in the GUI. So we need to call ICM 64. We need to call the MD script, which is in the bin directory. As I mentioned before, they have some arguments. And then this is, I previously ran this and I called my hit list something else, but you can have your hit list here, and then the object file, which usually is _rec.ob in your docking directory for your receptor, and then you run it. When it's run, you will see it will provide a number of different number of different files. So let's just go here. When it's finished, you'll get an ICB file called MD summary. We'll take a look at that in a minute. And you'll also get the object files from your MD run here and here. So let's first open one of the objects from our MD run. So I open ICM. It's going to delete. I'm not really interested in the original project anymore. Delete all. I'm going to have file, open, and then find that object, the original object. So this is what you'd see if you just run it as a regular MD in the GUI. You get the stack shown here, so you can see the stack. You can stop it, play it. You can see it has 22 snapshots. If you want to do some analysis, you can do stack calculations here. You can calculate the score and things like that. But I'm just going to undisplay the waters just for a second. Display ribbon, so you can you can have a look at the ligand vicinity as you go through the stack. But then it'd be nice to see some additional statistics of this snapshot to see how much drift there is in the ligand over time during our MD simulation. So then all that information is in the summary table. So you go File, Open, and you choose, in our case, it's CR, it was called mdsummary.icb. This gives you this table. It's the original table. And then there are additional columns. So it's given us three rows for the 3 ligands that we had in our hit list. You may probably have more. So it provides some information about how much the ligand has drifted during time. So you have RMSD 0, so the mean of the RMSD, and then the max, and this value is the RMSD is versus the initial docked pose from the docking hit list, and how much it moves away from the original docking pose. So if you see a very high RMSD, you would assume that the ligand is particularly unstable. So you'll be looking for quite small, relatively small numbers in this RMSD 0 section. min maximum here is 1.9 RMSD, and the minimum is 0.35. This value, the TCOV value, gives it's a value of the time covariances. So TCOV is time covariances, i.e. an indication of continuous drift towards higher or lower values. And these are plotted. You also see another column just called RMSD. This is the RMSD versus the snapshot after 1/3 of the simulation time. So the idea is that if the pose, the idea is that if the pose gets refined, it should stabilize reasonably soon during the simulation. So again, the lower the value, the better. And the final column is just whether this MD was a success or not, because you may have many hundreds. Sometimes, occasionally, the MD will fail, and it will tell you in this column 1 or 0 whether it's a success or not. So this is another way of filtering your hit list. You could remove those that have very high RMSD values and focus on those that are very stable in the binding pocket. Please see other YouTube videos on molecular dynamics in ICM.